Okay, so this is section 3.3 of Math 146. This one is specifically called unit circle trigonometry, which I have introduced in 3.2, and I'm really just going to kind of extend the idea and put this all into a nice visual um, unit circle, as mentioned. So if you remember that a unit circle is a circle that has a radius of 1, and that's going to be pretty important when it comes to finding the values around the circle. Ultimately, this section right here, the one that we're going to do, is going to hopefully give you ways to think about being able to figure out specific sine, cosine, tangent, and then the other three reciprocal identities, the values of those things relatively easily, or at least be able to come up with some kind of a pattern that will help. Um, it's slightly different than what you might actually see in your book as far as the way I'm going to describe it, but this is a good way to learn the unit circle, so it will be accurate and it will help. So what I'm going to do is I'm actually going to put up on here a picture of a unit circle. Give me a second there. I got to get that blue box off of here somehow. There we go. Okay, we already talked about the different quadrants that all the trig functions are positive and negative in. I'm just going to go ahead and put those back up here so that we remember. Remember in the first quadrant, and this basically is like we're on an XY axis here. Remember in the first quadrant, all trig functions are positive. In the second quadrant, you've got the sine and therefore the cosecant. Cosecant. Trying to draw this small, but it's not really working very well. Try this again. Cosecant. There we go. And in the third quadrant, on the lower left here, we've got the tangent, and therefore the cotangent. And then in the fourth quadrant, we've got the cosine, and we have the secant that are positive. So that tells you the positive ones. I'm not writing the negative ones out, so we can actually just kind of cross off the thing that says negative, because if it is not positive, then it is negative. So for example, in the fourth quadrant down there, since cosine and secant are positive, all other four are going to be negative. So we're just going to write the positive ones in there. Makes it easier to remember. Okay, we have talked about how we develop this. I'm not going to re-go through every single thing, but the idea is in order to find these specific ordered pairs that we have on the outside, we have to relate to some of the special triangles. For example, and I'm going to erase this so you don't need to necessarily put this on your paper, although if you printed several copies, then you can. This one right here would be formed by a right triangle. Whoops, a right triangle. And this specific angle right here is a 30-degree angle, which in radians is pi over 6. And we've already talked about how you get that. So since this angle technically right here was your 30, that makes this a 60, which is a 30, 60, 90 special right triangle. We know that the radius of every single one of these things is 1 because it's a unit circle, which makes our hypotenuse 1. And then because the relationship of a 30, 60, 90 says that the shorter side, or the side opposite of the 30 degrees, is half of the hypotenuse, that's 1/2. And then the long side is that short side, 1/2, times the square root of 3. So that gives us the square root of 3 over 2 right there. So the ordered pair that we're going to have here would be the x value, square root of 3 over 2, and the y value, 1/2. Okay, that's how you obtain this. You could do it for the 45 and the 60 and all the way around. Again, I'm going to erase what's here because otherwise it's going to get too messy. But that's how we determined that specific thing. I should not have erased the degrees and the radians. That's pi over 6. And then if we go around the circle, we would know that this is a 45-degree, which is the same as pi over 4. And then this one here is a 60-degree, which is the same as pi thirds. The ordered pairs that went with those, this one right here would be the square root of 2 over 2, unrationalized was 1 over the square root of 2, and that's perfectly fine if you leave it unrationalized. And then the 60 degree, the biggest thing you're going to want to remember here is that the 30 and the 60 degree are the same things, just the triangle is flipped, so that means that the x and y gets flipped around. Not flipped over, but just like the opposite, x and y. So then you get 1/2 and then the square root of 3 over 2. What I'm going to tell you is that with unit circle trigonometry, if you know this part, if you know the first quadrant, you also are going to have to know everything on the quadrant axes, the XY axes. But if you know the first quadrant, you can figure everything else out because it's all symmetric. Everything is symmetric. So let's take a look at the symmetric parts of this as opposed to the things on the quadrant axes. We'll talk about that in a second. If I were to go to what should be symmetric to the y-axis for 30 degrees, well, that's the one over here. That's this one right here. If I go to that one, well, it is also 30 degrees away from the horizontal axis, which makes this a 150 degree, because the horizontal axis is 180 on that side. So that's a 150. And this is the way I kind of try and figure these out. Now, you can come up with whatever way you want to, but this is my method. What I'm going to do is I'm going to say, okay, if it's 30 degrees away from the axis, that means it's got to be some kind of a pi over 6. So I know that this is going to be some kind of a pi over 6. But how many pi over 6 is it? And that's what you need to ask yourself. Now, you can always try to think, well, if I count around, I would have, 30 degrees, that's 1 pi over 6. Here's 2 pi over 6. That's 3 pi over 6. Then 4. And then that one right there, another 30 degrees is 5 pi over 6. And that is perfectly fine to think of it that way because it's literally what's happening. But what I would do is I would realize that, okay, so here's 1 pi over 6. If I go another one, that's 2 pi over 6. But 2 pi over 6 reduces because 2 over 6 reduces, which is why you have pi thirds. Pi thirds is the same as 2 pi over 6. And if you go to the next one, that would be 3 pi over 6. But again, 3 over 6 reduces to 1/2. So in this case, that's actually going to be pi halves. Then you go to the next one, which would be 4 pi over 6. But 4 pi over 6, once again, reduces. That's 2 pi over 3. And then the next one, well, like I said, once again, is 5 pi over 6. What you should realize is that's the first one after pi over 6 that does not reduce. 5 pi over 6 is the next, what I call non-reducible pi over 6. And the non-reducibles are going to be the ones that you're going to need to know in order to fill in or to kind of equate this in your head quickly. So if you think about it, the next one would be 6 pi over 6. But of course, 6 over 6 reduces to 1. So that's where you would just simply get pi. So the next one that is actually equivalent to our pi over 6 that's non-reducible would be 7 pi over 6. That's this one. And then if you, again, think about it, 8 pi over 6 reduces, 9 pi over 6 reduces, 10 pi over 6 reduces. The next non-reducible, which should again be 30 degrees away from the horizontal, is way over here, and that would be 11 pi over 6. And the nice thing about that is if you know your non-reducibles, so pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, it gives you 1 pi over 6 in each quadrant. It gives you the one angle that is exactly 30 degrees away, or pi 6 units away from the horizontal axis, and therefore all of the ordered pairs are going to be the same. The only exception will be the positive and negative signs, because you are going to be in the second, third, and fourth quadrants. So the x values will be negative in certain places, the y values will be negative, and so on. So you can very easily think to yourself, well, this is still going to be a square root of 3 over 2 and a 1/2 because it is symmetric. to the pi over 6 on the right-hand side. This one's still going to be a square root of 3 over 2 and 1/2. That's the 1/2. This one is still going to be a square root of 3 over 2 and 1/2. The only thing you really need to know now is what's positive and what's negative. Well, anything to the left of the y-axis, the x values are negative. So we know that that's a negative. I know that that's a negative. And then the one on the right-hand side, the square root of 3 over 2 is not. Anything above the x-axis, the y's are positive. So anything below the x-axis, the y's are negative. Well, that makes that one negative, and it makes that one negative. So now we've got the ordered pairs for all the different places for the pi sixth. Everything else works out the same. Pi fourths, you are going to look for the non-reducible pi fourths, and we'll fill those in. Well, in the first quadrant, it's 1 pi over 4, doesn't reduce. 2 pi over 4 would be next, but that would be at the top where pi halves is. 3 pi over 4 is the next non-reducible. So 3 pi over 4. Okay, 4 pi over 4 reduces, 5 pi over 4 does not. So 5 pi over 4 is down there. And then 6 pi over 4 reduces, but 7 pi over 4 does not. And each one of those is pretty much the one right in the middle of each one of the quadrants. It separates your quadrants nicely. It splits them in half. The pi fourths are probably the easiest ones to remember because it's simply all the odd numbers on top, 1, 3, 5, and 7. And that tells you what quadrant you're in. As far as the degrees are concerned, I think those are probably some of the easier things to fill out. You just have to know either how to add 30, 60, or 45 to numbers to get to the next numbers. I think we all pretty much should probably know that at the top it's 90 degrees. To the left it's 180. At the bottom, you're adding another 90, so that's 270. And then all the way around would be 360 degrees. Of course, if we didn't go anywhere in the first place, that would have been 0. All right, let's talk about, again, well, actually, let's finish off the radians. Let's do the pi thirds. So again, think non-reducible pi thirds. The first one in the first quadrant, 1 pi over 3. 2 pi over 3, we already have filled in. That was not reducible. 3 pi over 3 reduces, so the next non-reducible one would be 4 pi over 3. And then 5 pi over 3 does not reduce. So that's the last one, because then you would get back around to 6 pi over 3, which is 2 pi. So then again, just fill in the rest of the degrees. I know it was 90 degrees at top. I'm going to add 30 more to get to the next one, which is 120. The middle right there would be 45 away from 90, so that's going to be 135 degrees. That's the same as 3 pi over 4. Go to the third quadrant now. Again, 30 degrees away from 180 is 210. 45 away from 180 was 225. And 60 away from 180 is 240. Okay, and then go to the fourth quadrant. Adding 30 degrees to 270 is 300. Adding 45 degrees to 270 is 315. And then adding 60 degrees to 270 is 330. And then you would simply add 30 more degrees to get back to 360, which I didn't fill in. That would have been 0 right there for pi, and then 2 pi if you go all the way around. So now we should be able to think of this and say, okay, any of these pi fourths that are non-reducible, they're all going to be square root of 2 over 2 and square root of 2 over 2. We just have to include the appropriate signs. And again, in that second quadrant, the x will be negative, the y is positive. So then we've got square root of 2 over 2, square root of 2 over 2. Both are negative in the third quadrant. And then square root of 2 over 2, square root of 2 over 2, and only the y is negative in the fourth quadrant. Let's fill out the pi thirds. That's always going to be a 1/2 and root 3 over 2. So 1/2 root 3 over 2. X is negative. 1/2 root 3 over 2. They're both negative. 1/2 root 3 over 2. The y is negative in the fourth. So the only ones we really haven't talked about are the quadrant angles. We definitely mentioned those in the previous section, but if you think about it, this should make sense because if we're talking about ordered pairs, you don't really have to put a triangle to this if you think about it. The radius is 1, which means that the distance from the origin out to here, the x distance is 1 unit. And we did not move in the y direction, so the ordered pair is 1, 0. If you were to go vertical, it's just the opposite. We have a y distance of 1, but an x distance of 0. We did not move in the x direction. Going to the left, well, the x distance is now just in the negative direction, so it's -1 and then 0. And then same thing with the part in the bottom. That would be a 0, -1, because we moved 1 down in the y direction. So it looks like the only thing that I forgot to fill out was the radians at 270 degrees. And the radians there, if you think about it, so we're counting by 90, so that would be pi halves if you go to the top. Another pi halves is 2 pi halves when you get to the left, and then another pi halves would be 3 pi halves, or 3 pi over 2 for your radians. And then if you add another pi halves, that would get you to 4 pi halves, which is 2 pi. So again, there is going to be a ton of different ways that you could go about trying to figure these values out. This is what I will tell you. You probably should try to know the first quadrant, know how the other pieces fit in. So kind of know the symmetry when it comes to the x and the y axis as far as where the pi sixths are, where the fourths are, where the thirds are. Know what ordered pairs go with everything in the first quadrant. Again, what I did was I always picked one of them. I knew what 30 degrees was, and I knew how to figure that out because 60 degrees is always the opposite. I could just flip the x and the y around. And then the pi fourths or the 45 degrees were the easier one because the ordered pairs are both square root of 2 over 2. You just have to know what quadrant you're in for the signs, for the positive and negative signs. Whatever is going to be the easiest for you to figure out. This will not be something that you have access to when it comes to tests and quizzes. You need to know these values. It looks overwhelming if you look at this whole thing and say, oh my gosh, I have to memorize the whole thing. You don't. If you have some kind of logical way of thinking about how to fit it all together. You do need to know at least the basic stuff in the first quadrant. So why is all of this stuff important? Like I said, it's because we're going to try and now be able to figure out how can I figure out my sine, cosine, and tangent values easy if I know these values? Well, so we're going to think about it like this. I'm actually going to go to another unit circle because it's going to get too messy if I put everything on this one. So we're going to kind of relabel some things here. So this one right here, we're going to start with this one. And I am going to keep the triangle on here for a second for this piece. This was our 30 degree, which is pi over 6. And again, we know that the hypotenuse is 1. We know that that's 1/2. We know that that is √3 over 2. So that means that we're going to have the ordered pair √3 over 2, 1/2. Make that try and look like a 3 under there. Not great, but you guys know that that's a √3 over 2. Okay, we know that the sine of our angle, well, here's our angle. We know that the sine of the angle is the opposite over the hypotenuse. Well, if you look at this, the hypotenuse is 1. So really, in this case, the sine is just the opposite because it's the opposite over 1. And the opposite here is 1/2. So the sine of 30 degrees is 1/2. And again, for whatever reason, this is the one I chose to memorize in school, and then I just kind of figured everything else out from there. So the cosine is the adjacent over the hypotenuse. Well, in this case, again, the hypotenuse is still 1, so it's just the adjacent, which in this case, cosine of 30 degrees then would be the square root of 3 over 2 over 1, or just the square root of 3 over 2. And then the tangent. The way I always remember tangent, because it is the opposite over the adjacent, And we already know this because I've given this to you, but the opposite was sine, and the adjacent is cosine. You simply look right here. So I always figure tangent out by doing the opposite over the adjacent. So if I wanted to do the tangent of 30 degrees, and literally to this day, this is still how I think about this in my head. I don't have all these things memorized. I have the sine and cosine, but not all the tangents. It's 1/2 over the square root of 3 over 2. Using some basic knowledge of fractional division, because the denominators are identical, those things are going to cancel out, which leaves me with 1 over the square root of 3, which rationalized would be the square root of 3 over 3. Again, not necessary. You can leave it as 1 over the square root of 3. I'm perfectly fine with that. But here's the takeaway. What you should notice, and this is going to be this case all the way around the circle, the sine was the y value of that coordinate. So if you know that, then you know that the sine of some angle is going to be equivalent to the y value. The cosine was the x value of that coordinate. So the cosine of our angle is going to be x. And then the tangent, let's go with purple, is the sine over the cosine, so it is the y over the x value. Okay, and this is going to be that way all the way around the circle. All right, we do need to talk about some domain and range issues so that you have an idea what's going on. I think the best way for me to do this is I'm going to try and kind of draw a little box. I have no idea how this is going to go. So let's see if this will work with a square thingy here. If I can get this right in the center. Nope, that's not how that works. Okay, so I want to get rid of that. Okay, can't do it that way. I'm just going to have to hand sketch it. If I were to draw a box around, this is not going to be the best, but this is supposed to be a square. Hopefully you're going to understand why I'm doing it this way in a second. This will help with our domain and range. Remember that domain goes with all of the x values or all of the input values. Well, the inputs here are going to be your theta. So your domain has to do with your theta values. Well, in this case, sine, cosine, and sine and cosine specifically, let's start with those, can take on any value that we want to. Anytime that I have a sine value, which is in this case the y value, it's going to produce an output. It's going to give us an output someplace around the circle, no matter what value I pick for theta. So if theta is, pi fourths, that's here. If theta is 2 pi thirds, that's all the way around to here. I can keep going around the circle infinitely. There is no theta value that I cannot have. So in this case, for sine, the domain is all real numbers, or from negative infinity to infinity. Cosine, exactly the same thing. There's no value of theta that I can't put on there that's not going to produce some kind of an output. This is actually much easier to see when we get into the graphs in the next section, but it'll all tie together. Tangent has an issue, however. And tangent, whoops. Because tangent is sine divided by cosine, we should know that you can't divide by 0. So basically, whenever you get an x value of 0, you're going to have an undefined value of tangent. So tangent does have a restricted domain. Basically, it's saying that whenever your denominator, your x value is 0, it can't happen. So if you think about where the x value is 0, the x value is going to be 0 any place up and down the y-axis. And those are going to be on all of the odd multiples of pi halves. So tangent is going to exist everywhere except on all of the odd multiples of pi halves. Not really sure the best way to write that one as far as a domain, because that's a difficult domain to write out. But we'll just say it can't be any odd pi halves. Again, I'm not really sure the best way to say that. But basically, pi halves, 3 pi halves, 5 pi halves, going in the negative direction, negative pi halves, negative 3 pi halves, and so on, because you can't divide by 0. So whenever cosine gives you a value of 0, it's going to be undefined. Anywhere else, tangent will exist. And then if you think about the reciprocals, which I'll take care of with this box in a second here, well, actually, that's going to be more the range values, but the reciprocals are going to be similar to defining tangent in the fact that because sine is y, the y value, if you were to take the reciprocal of that, it would be 1 over y. So basically, whenever y is 0 or anything along the x-axis, cosecant would be undefined. I'm not going to write that stuff down here because you need to know these three, and hopefully that makes sense. Just make sure you can't, you're not trying to divide by 0 when you're talking about domain issues. Let's talk about the range real quick, because that's really what the box is here for. I'm going to try and slide this down now. Now just put the range down here. And this is actually really important. So the range is going to be your output. Well, if you look at the box, for every possible value, I'm going to talk about sine and cosine first. For every possible value of theta, I have an output. I either have an x or a y value. What you should see is that the furthest this box is, this is a 1 by 1 box. Again, think of this as being on an xy plane. You know, this right out here is 1, up here this is 1, so this is a 1 by 1 box. There are no values for sine and cosine that hit anywhere around that circle outside of 1, or, in this case, -1. So the range, excuse me, of sine and cosine says that the output can only be in between -1 and 1. So sine of theta, the range will be, from -1 to 1. And we do obviously get to -1 and 1 because that's part of it. So you have to include those in the solid brackets here. Tangents is a little bit different. For every value that's in the domain of tangent, its range can produce anything. Because if you think about it, these numbers can get super, super small, close to 0. They can get to 0. They can get really, really big, especially if you're going to start dividing really big numbers by really small numbers. They can get really big. So tangent, and this is a harder one to see because it doesn't really fit with my little box drawing here, but tangent is all real numbers. It will produce every possible output, negative to positive. And then if you think about the reciprocal functions, specifically with sine and cosine, since sine's range is everything inside that box, its range for cosecant and secant, which are the reciprocals, flipping it over is going to be everything outside of the box. So cosecant and secant's range are going to be everything greater than 1 or less than -1. Again, I'm not going to write that down, but again, hopefully that makes the sense. So if you were trying to find the cosecant of something, you're not going to get a value between 0 and 1. You could get 1, but you won't get anything less than in between -1 and 1. It has to be outside of that box because it's a reciprocal. You're flipping it over. You're changing the fraction. All right, so I think that is plenty enough to get you started on this. You're going to use this lesson in combination with the previous lesson as far as being able to try and figure out values. Remember that you're going to use reference angles to be able to get specific values, but the biggest thing for this lesson is you need to know how this unit circle works. You need to know the values on the unit circle. and you're going to have to come up with some nice way for you to know it without necessarily drawing the circle out every single time. Again, my thought process, I'll just run through one real quick. If I had to do, let's say I had to figure out the cosine of 4 pi thirds. Okay, so first thing I have to figure out is 4 pi thirds. Well, let's see, pi thirds, 2 pi thirds, 4 pi thirds. 4 pi thirds is a non-reducible in the third quadrant. And since it's a pi thirds, it's down here because it's going to be the equivalency of a 60 degrees away from the closest x-axis. So then I have to know what the ordered pair is. Well, since I memorized that sine of 30 degrees is 1/2, I knew the y value here was 1/2, meaning the x value was root 3 over 2. So if it's pi thirds, that changes. That's 1/2 here, and then root 3 over 2 here. It's going to be the exact same thing down here. So it's going to be 1/2 and root 3 over 2. And I'm not going to usually write all this stuff out. I'm just giving you hopefully a visual. And I am looking for the cosine of that, which is going to be the x value. And I know that since it's in third quadrant, both of these are negative. So cosine of 4 pi over 3 is negative 1/2. Okay, do I expect everybody to do it quite that fast, or maybe that's too slow for people? I don't know, but that's the way I still think about it to this day. I have to piece it together. I put everything in terms of what it would be in the first quadrant, fit it to whatever new quadrant it's in, and I know the values from there. All right, again, put this together with the stuff that we learned in the previous section, and you should have enough to be able to finish the homework on this one.